Okay, turning to fusion now. As I'm sure you're aware, none of our nuclear power stations are fusion reactions. They're all fission reactions. And that's because for fusion reactions to happen, we need such high temperatures and pressures inside the reactor that although we can do it, we do have fusion reactors that work, we have to put so much energy in to get these high temperatures and pressures that it's more than the energy we get out. So at the moment, it's not worth it, but we're working on it and they are improving. What that means for your exam is that whenever you're given an example of a fusion reaction, it's going to be the fusion reaction from inside a star. And for our sun, this is typically what you'd be given. So we've got 4 hydrogen nuclei, which is obviously just 4 protons, and they're going to fuse together and make a helium nucleus. Now, straight away, I'm sure you can spot something's up here because a helium nucleus is not made of 4 protons, it's made of 2 protons and 2 neutrons. So this is a summary of what's going on. Actually, what's going on are all of these fusion reactions. And here you can see we've got weak interactions going on where protons turn into neutrons, and that's how come we can start with 4 protons and at the end have a helium nucleus. Now, in the version you get in your exam, they do add in the 2 positrons that come out there, so you might see them sometimes, but we're ignoring the neutrinos that come out, we're ignoring the gamma rays that come out. So what we do for our exam is like a summary of what's really happening. But I thought I'd show you that because otherwise you might think, hold on, that's 4 protons, that's 2 protons and 2 neutrons, what's going on there? Okay, so this is the reaction. And we said that to get this to happen, we need very high temperatures and pressures. And so the really important thing to note here is that we've got to overcome the electrostatic repulsion. These are all positively charged, and so they repel each other. So how do you get 4 protons that are all positively charged and all repelling each other with the electrostatic force? How do you get them close enough together that they can fuse? Well, you fire them at each other very, very quickly. So remember that high temperature means they're moving very quickly. And when they're moving that quickly and they're squashed together in a small enough space, then they can actually get close enough together that they exert strong forces on each other. And that's what makes them stick together and ultimately end up as a helium nucleus. Okay, bearing all that in mind, here is question 3 today. Okay, so having just told you that all fusion reactions in your exam are in stars, this one looks like it happened in a particle accelerator, so maybe we're going to get Large Hadron Colliders in your exam as well. Okay, 2 protons fuse together, explain how they are able to do that. The strong nuclear force, that's the one that makes them stick together. And explain why the proton must have very large velocity. So you need to say the protons repel each other for the first mark, and so they need to be moving very quickly to get close enough together for the short range strong force to be able to have an effect. That's the second mark. The fact that you need to note that it's short range, the strong force. And I didn't say there for B, you had to say that the strong force is attractive. How do they remain together? Because the strong force is attractive if they get close enough together.